Methanol and gasoline are both liquids we hear of in our everyday lives, but not many people know exactly what they are. However, have no fear, for we, Mr. Methanol and Dr. Gasoline, are here to share with you all there is to know about us. Let's begin with methanol, shall we?
Being chemistry students, you all know from my name itself, I am an organic compound, belonging to the functional group of alcohols. In fact, I'm the simplest alcohol of all, with the molecular formula CH3OH. I have many nicknames such as wood naphtha, wood alcohol, but commonly known as methyl alcohol. You might be wondering how those names comes about. Well, long time ago, not that long, the ancient Egyptian obtained me from the pyrolysis of wood and utilized it in embalming. Yuck! However, it's not until later in 1661 where it's first isolated as pure methanol by Robert Boyle, a physicist who discovered the Boyle's law. Sounds familiar, right? He then produced it via distillation of boxwood and called it the spirit of box. I exist as a light, volatile, colorless, and is a very flammable liquid. And I do have this distinct odor similar to that of ethanol, but slightly sweeter. I am actually produced naturally by anaerobic metabolism of many varieties of bacteria, and a small trace of it can be found around us. Modern me is actually prepared by the catalytic combination reaction of carbon monoxide and hydrogen gas under high pressures. Lastly, I'm actually very useful. I can be used for a number of applications, such as transportation fuel, wastewater denitrification, carrier of hydrogen fuel cell, biodiesel transesterification, and even electricity generation.
Now, let's move on to gasoline. Remember that awful smell that fills your nose whenever you stop by a petrol station? That's the smell of gasoline, more commonly known as petrol. I'm sure most of you should be familiar with the term petrol, especially those whose families own motor vehicles, as rising petrol prices have been a problem that has plagued drivers for years. However, apart from the fact that gasoline is used as a fuel, what else do we actually know about it? Gasoline is a mixture of about 150 chemicals refined from crude oil. It's usually a colorless, light brown or pink liquid. It is produced from a fractional distillation of petroleum and is usually enhanced with additives to aid burning. Although gasoline was around before the invention of the internal combustion engine, it was considered a useless byproduct of the refining of crude oil to make kerosene, which was used as a fuel for lamps in the 19th century. The first oil well was dug in 1859 by Edmund, and the petroleum was distilled, with gasoline and the other products being discarded. After the invention of the automobile in 1892, gasoline became recognized as a valuable and powerful fuel for engines, and by 1920, there were 9 million vehicles on the road powered by gasoline. Next, let's find out about the energy conversion of both methanol and gasoline. Gasoline is commonly used in the internal combustion engine as a fuel, which follows a 4-stroke combustion cycle to convert gasoline into motion. The 4 strokes are intake stroke, combustion stroke, and lastly, the exhaust stroke. The piston starts from the top. As the intake valve opens, the piston moves down to let the engine take in a cylinder full of air and gasoline. This is the intake stroke. Only the tiniest drop of gasoline needs to be mixed into the air for this to work. For the compression stroke, the piston moves back up to compress this air-fuel mixture. Compression makes the explosion more powerful. When the piston reaches the top of its stroke, the spark plug emits a spark to ignite the gasoline. This is the combustion stroke. The gasoline charged into the cylinder explodes, driving the piston down. Once the piston hits the bottom of its stroke, the exhaust valve opens and the exhaust leaves the cylinder to go out the tailpipe. This is the exhaust stroke. Now, the engine is ready for the next cycle, so it intakes another charge of air and gas. Notice that the motion that comes out from an internal combustion engine is rotational. In an engine, the linear motion of the pistons is converted into rotational motion by the crankshaft. The rotational motion is nice because we plan to turn the car's wheels with it anyway.
Let's move into DMFC. The DMFC is a fairly new form of fuel cell technology that was invented in the 1990s by researchers at several institutions in the United States, which actually includes NASA. It utilizes a polymer membrane as an electrolyte, similarly to that of polymer electrolyte membrane fuel cell, or simply PEMFC. However, one distinction is that platinum niobium with a catalyst on the DMFC anode is able to draw hydrogen for liquid methanol, eliminating the need for a fuel reformer, which actually enables pure methanol to be used as a fuel. DMFC operates within a temperature range of 60 to 130 degrees C, and tends to use in application with modest power requirements, such as a portable power pack. The MSC power unit has also been used in various countries for material handling vehicles. Forklift trucks in commercial warehouses, which were conventionally powered by battery packs, are able to be refueled in a matter of minutes after switching to fuel cell, as opposed to hours requiring to charge a battery. Fuel cells also eliminate the needs for battery charging infrastructure within warehouses, thus saving on petrol space. After saying so much, I bet you're wondering what are the pros and cons of me, Mr. Methanol, and Dr. Gasoline. Well, I have several advantages over the conventional transportation fuels. I'm easily available, cheap to produce, and at a low risk of flammability compared to Dr. Gasoline. These are the reasons for the surge in use of methanol as motor fuels during the 1970s oil crisis. It can also be manufactured from various carbon-based feedstock such as natural gas and biomass. Furthermore, I can reduce the emission of carbon monoxide, hydrocarbon, and nitrogen oxide when compared to gasoline, a huge step in the quest to bettering the environment, especially when blended with Dr. Gasoline. I has an octane rating of 102, a measurement of performance of an engine or aviation fuel, higher than that of ethanol at 96 or gasoline at 86 to 94. I also have helped in improvement of human life. Being a polar liquid at room temperature, I can be used as an antifreeze, solvent, fuel, as a denaturant of ethanol, and even for producing biodiesel via trans-esterification reaction. On top of that, I can be easily made into hydrogen, and the methanol industry is currently working on technologies that will allow methanol to produce hydrogen for fuel cell.
As for gasoline, since it is a natural product of fractional distillation of petroleum, it is much cheaper compared to other fuels. It is also cheaper to maintain than diesel and is not hindered by cold weather.
However, there are always two sides to a coin. Before you get carried away with advantages of such fuels, we must also consider their disadvantages. Earlier on, we have learned that methanol is a flammable liquid that may explode when exposed to flames. It is also highly toxic in nature. Methanol can result in death if swallowed, breathed in, or absorbed in large quantity through the skin. Exposure to methanol can also cause visual problems and may lead to blindness. Chronic exposure to methanol can result in methanol poisoning, which causes inflammation of the eyes, recurrent headaches, insomnia, and even stomach problems. Subsequent exposure to methanol can also cause health problems inclusive of difficulty in breathing and diarrhea. Compared to gasoline, methanol is also more corrosive and has a lower energy content and can be more expensive.
As for gasoline, it is a non-renewable resource which we are slowly depleting. It is estimated that we will run out of oil in the next 50 to 150 years. It does not burn cleanly and releases carbon dioxide, which contributes to global warming. Gasoline also contains carcinogenic components such as benzene, which may cause cancer after long-term exposure. There are also political implications, as the world depends on the Middle East for oil. Although both methanol and gasoline have multiple benefits and have changed the way we live, they pose serious problems to human health and the environment. It is recommended that we look into other sources of fuel that are green, particularly biomass. Not only is biomass a renewable resource, we can also reduce our dependency on oil, reduce landfills and carbon emissions. Save the earth, save our children.